As I mentioned before, we're going to start it off with a short discussion from the Max Out team who won the IROS 2014 Microsoft Kinect Challenge. We'll let them talk for a few minutes, and then we'll move right into the panel on ROS. So, are you guys ready to talk?
Yes.
Okay, I'll turn things over to Greg.
If we could get my laptop up.
Make sure you hold the microphone.
First of all, I'm Greg Maxwell. I started SP Ross about a year ago, and we basically, in May, decided to do the challenge and had enough resources and people interested that we said, okay, let's try it. And the stars aligned, and we actually won the thing. So. Because of homebrew and the group that was affiliated with this, that it all kind of came together. So
tell them about the cash prize.
Thank you. We're supposed to get a check for $5,000.
It's in the mail.
What's really interesting is that the day after the contest was over, I was basically Monday. The contest was Thursday. Monday I sent a thank you to the guy who organized, and I got a bounce back email saying use this other email. They fired all of us. And so the whole Microsoft Research Robotics side was gone. So I sent an email going like, well, this check might be a little iffy. But I got assurance that, oh, talk to this guy and we'll get it. So I'm still waiting, I haven't heard. But,
So yes, the check's in the mail.
Check is literally, So hopefully we'll use that, and we're gonna. At the end of this, I'll talk about another challenge we're interested in.
Can you explain just in a couple sentences what the challenge is, because many people might not know?
Pretty much as we go through this, I think they'll get an understanding. But the challenge was to map an area and run through several waypoints in a specific order, and then they were using a software to kind of monitor how much time it took and the waypoints you got to and scored you. And then that, as you passed through kind of the loop, it got more complicated with people getting in the front of you, the furniture moving, so your map would be changed and see how smart you are. But they actually put in a hallway that caused everyone to blow up. So no one got past the third waypoint. So they had 28 waypoints and no one made it past the third. Some people barely got it to the second. So,
hey Greg, basically the only sensor allowed was the Kinect.
Kinect. It's all basically Kinect. So it's kind of like a very low dog field of view, showing a very narrow field of view that we used to get you around. So it's kind of complicated. But we started basically using ROS as a foundation, and we had a standard kind of G-mapper that you used with a Turbot and proof of concept saying, yeah, we could run this competition with this type of tools. And once we got there, we also discovered a library called RTAB Map. And RTAB Map uses a full Kinect point cloud to create a visual localization, visual odometry type system. So we were able to map the rooms very accurately, and it really was our advantage. Nobody else was doing it, we could not move as fast. And we actually got hung up because we had to go down this hallway, and the carpet was this repetitive pattern, and the hallways were made out of basic exhibition curtains that were about 3 feet tall, that were very repetitive. So you would just kind of go and think, oh, I've been here before, and bounce back a foot. Or the pattern was a yard. So I'd go back a yard and just stop and then think, oh, what am I doing? I have no place to go, I just bounce back. So that kind of shot our capability. We kind of figured it out a little bit later, and were able to run through the course a little better. But by that time we won, so who cares? So Ralph is going to talk about RTAB Map. Or you can, what we're doing.
Okay, well, the first thing I'll do is complete the demo so you can actually see the robot doing its stuff, and then I'll do some slides that I put together of the competition. So as Greg mentioned, the first challenge was to map the room, so I've been sort of doing that as what Greg's been speaking. So we did it in we broke it into 3 sections. First we'll go around and actually build the map, and then we can save the map. And with the RTAB map, it actually saves collected into a database. So when you put out of mapping mode, it saves that. Then we went into a second mode where we did create the waypoints, and within the arena of the competition, Microsoft had marked on the ceiling with fiducials, and on the floor they had some tape marking the location of their waypoints. And the way they were measuring you, there was also a Microsoft tablet on the robot during the competition that our computer had to talk to. So when we got to where we thought we were under a waypoint, we had to send a signal to the Microsoft computer saying, hey, we're at waypoint 1. And it had an upward-facing camera that would see their fiducials that we didn't get access to, but it would then use that to measure how accurate you really were at their waypoints or not. So during the sort of second phase, we had to stop at each waypoint and say, this is where we think waypoint 1 is, 2, 3, 4, and we create the set of waypoints. And then for the final phase, they gave you then a list of the order they wanted you to visit the waypoints in. There were 5 waypoints in total that they created, and 7 stops, 1 tour. So you had to go and visit a couple of the waypoints twice within a loop. And the basic structure of the competition, if you go around the first lap, the room is exactly as it had been during mapping. If you got past that and started on the second lap, then they had a bunch of people trained to actually interact with the robot that was driving around. They'd jump in front of it and stand in front of it, then walk towards it or away from it as it was driving along. If you got through the second complete lap with that happening, then on the third lap, if you managed to get that, they would start moving the furniture around. But as Greg mentioned, nobody even got past the third waypoint on the first lap anyway. So the Microsoft guys had a pretty easy time. But anyway, as I said, I've created a map, and we can show that up on the screen, and we'll show you the map we got out of it for the competition in a minute. I'll just finish creating the waypoints, and I hope we'll have that, and you can sit back and we'll see it loop around here for a couple of minutes.
So you have some kind of fiducial symbol on top of the robot or something?
Not right now.
No, we didn't have to.
Right now, I'm
The
just saying there's a
competition,
waypoint here.
yeah.
During the competition, there were fiducials on the ceiling and a camera on the back looking up that we didn't.
Camera on the robot?
On the robot,
Oh.
because that was connected to the Microsoft tablet that was on the robot.
And
But Camp, we didn't get to see that.
Yeah.
That was just for automated scoring purposes.
that's how they tell how accurate you were to hit the waypoint. Plus, they made these huge X's and a circle around it to say if the robot was there, you were in the waypoint general area.
That is a video. I will just run it.
So here's the video.
Have you had a video on that?
Yeah. Yeah. So here's us running over here on the screen.
And this is, are you driving that still?
Right now, during mapping, it's manual teleopt, so I'm just completing the waypoints. It's going to be our last
Say
waypoint.
waypoint button pressed. Waypoint 4 say
So we have
okay.
voice, you couldn't see the screen away, so we've got a voice feedback to help us see it. But you'll see this is the actual competition run on the screen. This is on autonomous mode after we've mapped.
Is that audio coming through your computer?
Yes, that's just coming out of my laptop there.
I think that's, what's the voice software you using?
It's
Sphinx?
festival.
So when we're stopped here at the waypoint, it was sending a command to Microsoft's computer saying, hey, I think I'm at waypoint 1. It's using its upward-facing camera, verifying against the fiducial on the ceiling. We got an acknowledgement. It said, yep, we got there, so now we headed off for the second waypoint.
And these ottomans are right below the camera's field of view, and they hung everybody else up.
So that's autonomous there, right?
Yes,
Yep,
this is
so that's
autonomous.
autonomous. Yeah.
So you can see we got
You're
within the
rounding
circle.
back there controlling.
Now we stopped and we said, okay, we're at waypoint 2.
Sphinx?
How did you identify waypoint 2?
That's in
I
the
mean, just
marking
from
phase.
the cross on the, I mean, during the marking phase, I press a button on the Kinect on the controller when I stop there. Just in sequence, they told you what.
So we're going to
number
show
they
it run here. We just did that same process.
But Ralph, during the autonomous phase that he's in now, he was, the robot's only localizing itself based on its internal map.
were. Yes.
Yeah.
So we're hoping he's at that waypoint by virtue of its localization.
Yeah, so this is the,
But it's
Guys,
all
I think we
odometry
can-
at that point.
no, well, and
all
the
they
software
don't
we talk about uses 3D
understand the
visual
beginning process.
localization.
Pardon me?
I don't
So
think
it's-
people
so
understand
this is
the
where
whole
we
process.
got to our
that
third one and then we
you
crashed into
mark
the
the
chair.
map manually and
And
then
this is our second run, wasn't it?
Okay, yeah. Hey,
This is our competition.
So
This is where we-
yeah,
Ralph, do you want to just give a little bit more detail about our tab map?
I will,
Oh, okay.
let's do it, see if we can actually get it to work now.
I
and-
can, while you
I've got
do
some
that, I
slides.
can,
I've got some
I can
slides.
talk
I've
about it
got-
really quick if you want.
But we just created our 5 waypoints here, and we'll see if we can get it to run a lap around here on its own.
That's a good idea.
So I'm putting it into mapping, to navigation mode now. It's going to use the map that it created just now as I drove it around, the list of waypoints. Now, the first thing we do is we drive it around. The software we use actually can handle global localization. It's using visual pattern matching. So we can just manually drive it a little bit until it recognizes where it is and it'll localize itself within the map. And then it should take off and start driving the tour that we gave.
Navigator ready.
So I'm not sure if it's actually local. There it just jumped, so now it's
Starting from
localized.
waypoint 0.
This is going autonomous.
Set and go waypoint 2.
What have you set a goal in Orbis?
Correct.
Well, during the mapping, during the landmark phase, we pressed a button on the controller when we parked at a waypoint, and now it's trying to go back to those points that we marked.
So the way Melanie was putting it, which I think is very good, is initially we create a map. That's the first phase. We create a map of the room. Think G mapping, you know, with the 2D map where the obstacles are and the walls are and things like that.
From
And then we
waypoint 2.
manually, just pretend that we went in and manually, we knew exactly where the waypoints were, and we manually marked them on the map. But now, in autonomous mode, the robot has to find its way to those manually marked waypoints all on its own.
That's where
You
you
see
use
here,
our key.
this
Exactly.
power
Yeah.
hutch is where
Because-
I parked on that when I was driving around just before and said that was a waypoint.
Mhm.
It's gone back and parked on top
Reach
of it.
go waypoint 1.
So if you're doing this at home, you can put a little piece of carpet tape on the waypoint, say, okay, this is gonna be a waypoint, set a waypoint, put a piece of carpet tape on there, and then later test to see if the robot can get there back on its own.
So can we actually wrote software, extra and ROS nodes, so instead of having to manually click on RVias to create that target, we had software that generated the target for us, based on some software that we wrote that's part of the package that ties, it's another ROS node that talks to the controller.
And just really, just to
So now
give
it's-
people a,
It's going
just,
through its cost map and going to its second.
So you
waypoint.
see it's now gone round, so we'll test it now,
Reach
it's going to
go
come back to
waypoint
one of these
4.
waypoints, I'm not sure which one.
And if we stand in its way,
Starting
it'll
from
navigate around
waypoint
it,
4.
we hope.
Set and go waypoint
Or else
3.
we, have an ankle
So if we stand in the way, it actually can avoid.
It does that
avoid an
beautifully, and now we
obstacle.
got to that part of the test.
yeah.
The thing you need to stress, it's not using wheel odometry.
It is partly, yes.
It is using.
Yeah.
Wheel and
It is.
visual, it's the whole.
Think of it as like
Slam.
G-mapping uses a laser scanner, but typically, and wheel odometry, and sometimes an IMU, right, for rotation. Whereas we're also throwing in the actual visual information from the camera.
The 3D. So the RTAP, what the RTAP map does is it takes, in addition to doing like the laser scan, it's taking visual pictures of pretty much everything it sees. So you get a picture of like the laptop with the table and the table leg with the podium nearby it. So when the robot tries to come back around and actually navigate to the waypoints that you mark, it looks and goes, you know, I have a picture of this carpet with a table leg and a laptop sitting on it. Is there a bench nearby? Yes. Okay, so I know where I am on the map.
Does it reset the wheel odometry based on its current observations? And
Yes.
Yeah, I would think it would have to.
And that's one
Now,
of the
can we
problems.
get this, hopefully I can get this
So
one.
then we'll-
Yes.
That's why we're gonna get down the hallway. Because it transported back to the mat previous
Oh,
to it.
because of these patterns on the floor?
Testing it.
Yeah.
It's CPU intensive.
It's mostly CPU intensive because to get the speed, it's storing most of that in memory. It's storing the pictures for later, basically later use. Like one of the things that we were very fortunate to be able to get the guy who wrote the software, Mitsu Lab, to work with us on this because this is his software and I think this is his thesis. So he was very eager to be helpful. But one of the things that we did later was he went through that database of all the images and we went back through and we picked out for certain corners, certain spots where it just couldn't automatically find a best match. He went back through and through like basically all the images. We have essentially a video of our entire run through the mapping software, and he manually matched, for a handful of things, manually matched this is the correct this is the correct resolution to this problem. This one right here is the correct, the best match for this orientation. This one is the best match for this orientation. We had to do that for I don't know, maybe half a dozen out of thousands of images, possible candidates. And then that once when you go in, you do that manually. Then the the scene just snapped into place, because now it has sort of like this key picture, and all the ones surrounding it that were also possible candidates for other positions, now all those, the score on those just goes way up, and everything makes a lot more sense. So we could see, like, when he picked one of these key pictures and was like manually kind of sewed things back together, that this sort of broken hallway would suddenly just unite, and you have a straight line, clean corner.
If I can get to my presentation here, I can show you what.
Question. Did you know you're going to have that crazy carpet pattern? And did it help hurt you?
No, and it almost killed us. The really kind of the interesting thing is that we had been practicing for a couple days up in another wing of the hotel, and we had another carpet pattern that was just offset enough that when you were looking at like a corner, or you're looking at a door jamb, you're looking at like, where one of the staircases was or something like that, the napping of the carpet and the offset of like, it had this different repeating pattern of like multiple designs. And that was actually really, really good. I mean, like the robot might have almost as well been on rails in some cases, because the matching, the visual matching, visual odometry was amazing. And then we got downstairs, and the image that we were the carpet pattern is instead of like this repeating pattern of multiple signals, multiple designs that are kind of not repeating exactly. It's one pattern with two identical things that no matter which way you rotate it is symmetric. So it doesn't matter if you're facing this way or this way or this way. There's always going to be this one design with chevron here, here, and here, and
Wow.
we ended up we went from like having like, oh yeah, we're totally going to rock this, we have it solid, to like, well, holy crap, what the heck are we going to do?
Houston, I think
In
there's a
testing,
problem.
we had it running down a hallway in the hotel, and they were kind of saying, well, if a person jumps in front of it, what would happen? And I go, well, if they do it right in front of it, won't have time to think, will run into you. And so we actually tuned down how fast it was going, so that you could actually not get.
Okay, well, I'm not able to get this up in full screen, it's a weird thing, so hopefully you can see enough of this from the little slide here. So this is basically an overview of RTAB map, and this is what happens when you don't have RTAB map. It's kind of the old-fashioned, you have a robot that has a laser, you use G mapping, and it creates a basic 2D map from the one-dimensional laser data. And that would be during mapping, and then if you're doing any sort of navigation, you would again use the laser scan, and the AMCL package matches that to the map and uses move base to move you from one level to the next. So when you bring an RTAB map, your world gets a whole lot messier. RTAB map, again, you have your robot, but now it's not only using the laser scan, it's using actual visual imagery, and it uses SURF or SIFT. You can actually choose your SURF as the default image feature points within that. It uses the full 3D point cloud, and that goes into RTAB map, and RTAB map produces out of that your 2D map, a full database of all of the images and the features that were detected within those images, and a 3D map. So having that rich set of data, which basically now gives you 1D, 2D, and 3D data during some sort of activity as we were navigating around here, you've got that rich set of data. So it uses the image and image features. It localizes, and what it calls a loop closure, everything it refers to as a loop closure, which during mapping says, oh, I've seen this point before, and it helps it close up. Because normally your odometry would drift, and you see maps sort of peel open. But we're using the visual imagery and the key points within the images. When it sees the picture it's seen before, it can close that and make the map a lot tighter. During navigation mode, if it sees a picture that it's seen before, it uses that to do global localization. So the kidnap robot problem, it can just, you start driving around and suddenly it sees I've been here before, and it'll jump on the map to the correct position in the map.
Does this take place in G-mapping in addition to
No,
2D?
we don't even use G-mapping. It takes
RTAP
overlays.
This is a totally different approach.
For G-mapping and 2D
AMCL, it
mapping.
replaces both AMCL and G-mapping, so it creates its own 2D map, and RTAP map does its own localization and control. So you can see you guys got a whole lot of much richer data. So the basic key points, it actually stands for real-time appearance-based mapping because it uses the visual imagery.
And this is a ROS node.
It's now available, it's available as
It's
a
available
ROS.
as a wrapper. It's a library you install on your laptop, and then
I mean, you
there's
have
a
to-
ROS wrapper. that then
You actually have to
calls.
install RTAB map, and then there are some ROS plugins that you can use to use it from within ROS.
Does RTAB map depend on Kinect, or can it work with
It's
any?
keyed off Kinect, but I presume it could work, not just the Kinect, it uses any of those family of sensors. But you could probably use, if you had a 3D laser that gave you a point cloud, it could
What
pretty
if
much.
you had a camera?
Stereo.
It does use the point cloud, the depth data, as well as the visual imagery.
But there's also a stereo camera method where it makes its own kind of point cloud off the stereo camera data. So
So
it
I've
can
emph-
actually work in a stereo camera mode.
Yeah, so I've emphasized just the 2D images and surf features. It's actually multi-layered. That it sees just the 2D video image, which any camera could produce for it, does the surf features, sticks them in a database. It also, when it sees what it calls a loop closure, which it uses just for when it's driving down a corridor, not for closing a loop. Maybe it's gone around a hallway and come back from another direction. But as each sequence of images, it matches against the previous one. And when it thinks I've seen this image before, maybe from a slightly different perspective, then it uses the 3D point cloud to do a geometric transformation to figure the offset between them using it, so it'll refine itself using the 3D point cloud. All of that feeding odometry in. So underneath is RGB DSLAM, and then the visual matching does enhanced loop closure on that. So there's layers and layers that we didn't even get to. I mean, the set of parameters is about 50 different parameters you can tune to get this thing to work. So.
We'll not run out of Eagle on Black.
On the demo page,
No.
they have a demo where they're not using wheel odometry, they're just walking around and making.
So the other thing it'll actually generate visual odometry from you by using the surf features, kind of the way the Tango tablet does it. So it'll actually generate odometry just by simply holding your scan and build a 3D model of a room or something just by holding the Kinect and waving it around. So, I mean,
I wanted to get Gertz up too, so if we could.
Yeah.
One of the parts of, making this successful, and I think that's, you enter a contest, you try to figure out how to work, and it kind of naturally kind of grows with the people you have. Gertz was able to make a simulation of the entire room, run the robot using the simulation, and basically it collapsed right at the same point the real robot collapsed. So we could figure out how to fix it, not having to have a robot, but just playing with RTAB preferences within his simulation. So, that's, I think, when you talk about ROS and what's going on with, how to build and run a robot system, the simulation part that ROS provides you and the way you're able to have these different things interact and fine-tune is one of the powers of ROS.
And just to put in a plug for OSRF, that's the gazebo simulator, not just any old simulator.
Oh, yeah.
Right?
Yeah.
So I have a video here but we'll maybe show that later of the map being built.
And we can talk all the time after this. too.
Yeah,
We'll be
probably
here to
shouldn't
demo.
take up too much time of a scheduled presentation.
We're considering it's a talk about ROS.
I will just show quickly the simulated room we ended up with.
AMCL. Automatic Monte Carlo localization.
Really that clean?
Okay, so we got pictures of the carpet and
Pictures of the curtains.
and the curtains, and yeah, so we made this whole test area available for testing. And so here you can see this long repetitive hallway. And that was really
Gertz, you had this done before you guys ran the competition?
Right during the competition, we realized Wednesday night we had a problem. Thursday morning, when we were like getting the competition, he's trying to work out a solution in simulation.
Were you allowed to run the robots in the room before the competition, or?
Not
Yes.
really. We tried, but we were pretty much out of time. We got there early and kind of ran and all that stuff, but there's
But they
people
allowed
around.
They allowed you to run.
But you couldn't really run the whole thing. You couldn't set waypoints. You could kind of map. So
They set it up on Thursday night, starting about 8 o'clock.
Wednesday
This-
night.
this-
Wednesday night.
Was it Wednesday? Sorry.
Yeah, Wednesday night.
This area was the exhibit hall for the conference. So up till Wednesday night, all the exhibitors were there. They broke down. We
So
finally
you
got
can
in
run?
late Wednesday night. They built the arena. But the Microsoft guys had their whole rehearsal that they wanted to do for how they were going to interact with the robot. So they spent about 2 hours going through pretending that a robot was driving around, figuring out how they were all going to interact. So it was difficult for us to get in and use the space at that time.
I would
Wednesday at
sure
2
be
o'clock,
decorated.
at like 1 a.m. in the morning, we figured, okay, we'll make 3 waypoints. Hopefully nobody else will do any more. And we'll work to see if we can do any better. So, but this is, this is one of the things that I think is kind of incredible, that you can have the simulation. All right.
The fire hydrants are not authentic.
But, okay, is that it? Do you want to show something else?
Well, I don't have anything to show, but I can tell that having ROS was incredible. So we had just, 10 weekends from the time we were accepted to the competition. And we
Correct.
started with nothing, with no robot, with basically nothing. And then we just started to run simulations.
Are you online?
We got there.
You get to the IROS map website and can play his video while we're talking. I'll do the mapping build.
So,
And so at some point we actually got the robot, and it was amazing how we just downloaded the software, and within minutes we had full control of a robot we had never seen before.
yeah, we basically had a joystick running this Pioneer robot within, I would say, an hour of figuring out how to connect it and turn it on.
And one of the things before we got the Pioneer, we started working with our turtle bots. And I developed, as I said, there's some custom code we wrote that generated the waypoints and instructed the robot to follow the path back to the waypoints. So we were able to develop that using a turtle bot. And I think Patrick also was using that within a simulated environment, not an accurate one, but just created another room to test that code in ROS, and we just plug and play it in afterwards. So this is a video that Mathal made from our database during the competition of the map that was being created. You can see the visual features being detected.
And this is all playing back from a database. So
Is that like a ROS bag or something?
It's actually the MySQL database.
the MySQL
So it's
database.
200. The database was 217 megabytes.
Really? But, it just goes through and starts creating all this stuff. So,
So one of the things you could do, Camp, you had a question, you said, you wondered if it was ROS bag?
Yeah.
So you can actually drive your robot around and collect and store, do a ROS bag record on the video images and the laser scan. And then you can actually run the entire thing in Gazebo in simulation from that ROS bag file, and then just play with all the parameters and just run it over and over again until you get something that seems to work okay with simulation. It won't guarantee that it'll work the same way with real robot, because the simulation's not perfect, but it does a pretty good job.
so Patrick,
So that was my one role, and these guys deserve all the credit. I came into like the last 2 weeks of their effort, and in fact, I actually learned 10 times more than I contributed, especially about this RTAB map. But one of the things I was able to do was sit at home while they were working over there in Chicago and just run a bunch of simulations, especially on the move base parameters, to get the cost maps right and so on. So it would go around, because if you don't get those right, in fact, it's incredible. If you get just the goal versus the path parameter ratio incorrect, the robot will always run into something instead of going around it, even though the object's right there in the cost map. And you can determine that in 5 minutes in Gazebo. And because I didn't even have the Pioneer at home. These guys had the Pioneer somewhere else.
and he was actually running a complete copy on his Pi robot
And I was doing it with PyRobot as well.
So a whole
there's-
different robot, running the same stuff,
the
telling us how to
class
set
map
up
parameters in
the run.
for move base.
Okay.
Yeah. In particular, the G disk scale and the P disk scale. So how much it hugs the path that is planned versus just gets to the goal. Turns out you really just want to get to the goal. Yeah. You want to kind of forget about the path, basically.
Yeah, so that last website, if you just Google RTAB map, you'll find the website on RTAB map. He has a page now with a whole bunch more detail about that. The database you can download from his website.
I'm interested in the losers that did the dust because of your victories. What strategies did they do? Did they use ROS? Where did they fail? Was it hardware, software?
Pretty much it was the ottomans. I don't know if you saw them, they're little black ottomans
Right.
tangled up 3 of our competition. So there's 5 other groups. One guy was kind of doing a cost map every 5 feet type of thing. He was doing pretty well, but again, couldn't make it through the hallway. But he was slow because he was making maps all the time. We beat him because of speed.
Who exactly was your competition?
Yeah, what were they using? They weren't using your system.
It was all Ubuntu based. I think just about everybody was ROS. There was one guy we weren't sure if he was using ROS or not, but it was definitely on Ubuntu.
Was it individuals or schools?
There was a mixture of schools, and yeah, so there was like I think 4 teams. There were 4 other teams. There was us, and then I don't know if you guys remember David Liu, who wrote a good chunk of the nav stack in ROS. So he was competing. He's now Dr. Liu, and he was competing on his own. I would say I've thought about this. I thought about because we're all kind of, when we were prepping, everybody was kind of in the same room together, and we had to share robots to test our software because there are only a limited number of pioneers in Chicago, that you could use to. So people had to share and trade robots, and my personal opinion is I think well, first of all, we put a lot of time into this, a lot more time than we kind of got obsessed about this and put a lot of time into it. The other thing is that I think we won on a number of operational points. We were, with one exception, we were not making or even developing major chunks of software until an hour or 5 minutes before the contest. Some guys were still putting in major features right up until they were told that they need to be ready to run. Not securing your laptop to the robot. Not really having a grasp of what zero-conf networking is, and just simple things like that. Saw one team had a hardware failure. They had to rectify that, which is not something you can exactly. Their laptop just basically died. They were using an old beater laptop that one of the students brought along, and that died, and they had to go out and get a new laptop. But then there is just simple operational stuff like I said, the networking. Not knowing that you can get by with a crossover cable, and you have to go out, spending time to go out and get a hub and try to configure things, and just losing a half a day to that kind of stuff. So I think my opinion is we had really good software, and we also had kind of really good operational awareness.
And you brought
And we sucked less than everybody else.
Yes. We sucked less. Yeah.
Ahead of the others, it was just they were a little bit behind us.
So I want to kind of end our time here so we can get on to the ROS thing. So I just wanted to thank you again, and we are going to kind of keep the team going, and we're going to, I haven't heard back from NASA, but we're going to compete in the Mars sample recovery contest in Massachusetts, June 8th and 13th of 2015. So this group's going to continue on. Hopefully if we see a check from Microsoft, we'll use that to fund it.
Yeah.
But, check our SV ROS user group on Meetup for details if you want to participate. I don't know, Tully has put our kind of press release on the front page, or is on the blog. It's the top blog of ROS.org. So you can see details about what's going on. SV ROS, the meetup brew.com/sv-ROS. You can see our things. We have some web pages you can go, it has the same information on it. And again, I want to thank everyone at Homebrew for allowing us to
Yes.
kind of put this all together and bring the group in this community so we can be winners.
Thank you. Yay robots. Yay robots.